Hello everyone again, and in this video we want to do this example. It's a garden hose attached with a nozzle, and we want to fill a 10-gallon bucket. The inner diameter of the hose is 2 centimeter and it reduces to 0.8 centimeter at the nozzle exit. So it takes 50 seconds to fill the bucket with water. We need to determine the volume and mass flow rate of water through the hose. Okay, so we assume that basically the flow is basically incompressible. So we assume that the water is an incompressible fluid, and it's a steady state flow again. We can assume that, and we can also assume that the density of the water is equal to 1000 kilogram per cubic meter. And what else? Let's see. So we have this information, right? We want to calculate the volume flow rate. So what is volume flow rate? I think it's pretty simple. So volume flow rate is volume per time, right? So how much volume is passing? 10 gallons, right? So that's 10 gallons. And in how many seconds? 5 seconds. But if you want to convert it basically to liter per second, reported in that unit, we need to do the conversion. And what we can say is basically each gallon of fluid is equal to 3.7854. And if we do that, then the result is basically 0.757 liter per second. So that's basically our volume flow rate. Now, how about the mass flow rate? I think that's also from the equations that we have. It's pretty straightforward. Density multiplied by volume flow rate gonna give you the mass flow rate. So 1000, which we assumed is the density of the water, multiplied by 0.757. But please notice this is in kilogram per cubic meter. So what we need to do is basically change it to kilogram per liter. For density of the water, in order to be in kilogram per cubic meter, per liter, that's equal to 1 actually. So this is 1 kilogram per liter. That's the density of the water. And the unit of basically 7.75 is liter per second. So it's basically 0.757 kilogram per second. So that's basically the first part of this problem. Pretty straightforward. We just need to calculate the volume mass flow rate. Next, we want to calculate the average velocity. So remember the relationship between the volume flow rate and average velocity. So volumetric flow rate was equal to the cross-sectional area multiplied by velocity, average velocity, right? So average velocity is going to be equal to volumetric flow rate divided by cross-sectional area. This is 0.7575. What is the cross-sectional area, right? So the cross-sectional area, since we're considering at the nozzle exit, right? That's what we want to calculate, right? The cross-sectional area is equal to pi r squared. So pi multiplied by, it's 0.8 centimeter in diameter, right? And therefore this is 0.4 centimeter in radius, and 0.4 squared is basically multiplied by pi. That's 0.5027 cubic centimeter, square centimeter. And then this can be converted in meter squared, of course. 0.5027 multiplied by 10 to the negative 4 meter squared. So average velocity is equal to 0.757, which was basically your volumetric flow rate, and that's basically in liter per second divided by your cross-sectional area, which is 0.5027 10 to the negative 4. This is in meter squared. We need to convert liter to cubic meter. Straightforward again. 1000 liters is equal to 1 cubic meter. Therefore, this is 15.1 meter per second. That's your average velocity of fluid at the nozzle exit. Please notice that your velocity inside the hose is smaller. Can you find that? Try that home and see if you can basically find the velocity of water flowing through the hose, not through the exit nozzle.